Identify the product of the following hydrolysis reaction. So hydrolysis means that you are adding water and you are breaking apart. So adding water and breaking apart. So we need to decide how we are breaking apart this molecule. And so we have a couple different ways that we can identify this. So if we're familiar with a reaction, we don't need this IR data. If we're not familiar with the reaction, maybe the IR data would help us to identify the functional groups. So I'm going to look at the reaction first to get to the product, and then we're going to go through and see how the IR could help us. So we want to recognize what this starting material is. And so we've got a carbon-nitrogen double bond. So this is an imine. So imines are formed from aldehydes or ketones. Aldehydes or ketones. And primary amines. So what we're going to see here is we're going to see when this breaks apart, this is a reversible reaction. So when you form an imine from an aldehyde or a ketone, you draw out water. So the reverse reaction is going to be that adding in water. So here's a nice, easy way to get to this final product. So I'm going to show you this first. I've got my trusty pencil here. So I want to identify what was my carbonyl carbon, because I would have a carbonyl if I had an aldehyde or a ketone. And that's easy to spot because it's the carbon that's still in the same oxidation state. So that oxidation state of an aldehyde or a ketone comes from having a double bond to oxygen, which is more electronegative than carbon. So a double bond to nitrogen. Nitrogen is also more electronegative than carbon. So that means that this here was my carbonyl carbon. So I'm going to label these on the original structure so I don't clutter up what I'm about to erase. So this came from the carbonyl in this reaction to form the imine. The nitrogen comes from, obviously, the primary amine. So if you want to take this backwards, all we got to do is erase this double bond. The nitrogen was the primary amine, so we're going to throw 2 hydrogens on there. And we would have had a carbonyl, right? And so what we also want to notice is that there is also a hydrogen on this carbon, because we can only see 1, 2, 3 bonds. And since carbon makes 4 bonds, any bonds that are not explicitly shown are assumed to be hydrogen. So we know that we had a hydrogen there to start with, which means we still have it in the product. So this is an aldehyde, and we can number the carbon chain to see how long, 4, 5. And actually, we've only got one answer here that's got the aldehyde and the amine. So we'll count to make sure there's not an error, but there should be the right number of carbons here. All right, so that is the right answer. So we got that with some knowledge of our reaction. But for review, let's also take a look at the IR spectrum. So we see in this range of around 3,500 and 3,300, 2 broad medium intensity bands. And so this is the area where we might see something like an OH or an NH. So the fact that we see 2 tells us that you have a primary NH2 group. So that could be a primary amine, or it could be a primary amide, would also be similar. In our case, it's an amine. So we'll say it's the primary amine. And then the next thing we have is this cluster of peaks just below 3,000. We should be used to seeing those. Those are sp3 carbon hydrogen stretches. So we see that a lot. Whenever we have sp3 carbons with hydrogens, you come across these peaks. These 2 are fairly characteristic. These are lower than your other CH type stretches. So these are also CH stretches, but in this lower region below the sp3 region, that's really characteristic of an aldehyde. So these are your aldehyde CH stretches. And then finally, if you have an aldehyde, you expect to see a carbonyl. And that's what we see here at 1720. So that's the carbonyl of the aldehyde. So 2 different ways we could have solved this, right? We definitely want to make sure we understand all of this. But by working backwards, we can get to the structures, and the IR, we can figure out the functional groups. And of course, there's only one molecule that contains both a primary amine and an aldehyde.